Okay, so let's look at this. Okay. By now, you must know what is acid, what is base, what alkali lah. Okay, so this one they put here aqueous, and sodium is group 1. So you need to know it's an alkali and it's a strong alkali. Okay, and then the second thing you need to know is this one, calcium hydroxide, is also aqueous, but the pH is not as high. Okay, water is 7. This one is ethanoic acid. This is the only weak acid I taught you. This is in vinegar. Okay, and this is strong acid. Right. So these are the three things that you need to. So define the term base. So if acid is proton donor, base is proton acceptor. Okay, an alkali is a soluble base. Okay, so the color of chymophthalate. So remember the indicators not. Remember the indicators? There are three indicators that you need to know. Methyl orange, litmus, hemophthalate. Do you remember the colors? Blue. Yeah. Okay. So you need to remember the colors in acid, alkali, and neutral. Okay, you need to remember the colors. So we've gone through this quite a few times already. Methyl orange in acid is red, in alkali is yellow, in neutral is orange. Litmus in acid is red, in alkali is blue. There's no such thing as neutral. It depends what paper you're using. Okay, if you're using blue litmus, in acid it turns red. Red litmus, in alkali it turns blue. Okay, thymophthalate in acid is colorless. Alkali, it is blue. Neutral, also colorless. All right. So thymophthalate in sodium hydroxide is blue. In acid, it is colorless. The problem with this is all of these indicators do not tell you the pH. So what happens is in litmus, for example, these two will be blue and these two will be red. That's it. Okay, you won't know the pH. So these indicators only tell you whether it's acid or alkali. They don't tell you the pH. In order to know the pH, you must use what? Universal indicator. Okay, you must use universal indicator. Got it? Okay. Use the information to identify the substance with the highest concentration of hydrogen ions. So in order to have highest concentration of hydrogen ions, it has to have the lowest pH because it has to be the strong acid. So nitric acid. Lowest pH. Name the indicator which can be used to identify the substance with the highest concentration. So this one, you have to use universal indicator. Do you know what they're trying to say? Okay. With the highest concentration of hydrogen ion is basically saying, hey, which one is going to tell me the pH? That's it. Okay. All right. Joy, okay?
Yeah.
Okay. Now the second page, okay, this one, I think you forgot already lah. Weak acid is the equation that is reversible. So it's CH3COO negative plus H positive. Okay. This one I told you last week. Okay. When we were doing the salt equations. Ionic equation, neutralization between any acid and any alkali. Now, this question doesn't ask you to do state symbols. That's why it's only 1 mark. But if another question asks you to do state symbols, it's usually 3 marks. Aqueous liquid. Okay? Alright. Okay, this one the calculation one. Dilute nitric acid reacts with aqueous calcium hydroxide as shown. Okay, so every time you see this, you must use the formula mv over 1000. Straight away, it must click in your head. mv over 1000. So mv over 1000. Okay, because this is the information for calcium hydroxide. Do you remember the formula? Yes. Okay, can you try and finish the last two? The last three, sorry. This. Ijo, you haven't done right.
No, I have not.
Okay, I give you the first clue already. You all try and do the next three. Okay? So in order to find the amount of moles of nitric acid, you must remember this one, the ratio is 1 to 2. So times 2 will divide by 2. Times 2, okay? So 0.0006. And then the concentration, remember 0.006 is amount of moles. M is what you're looking for. V over 1000. And the V in the question is 25 centimeter cube of nitric acid. Okay, so how much do you get? You didn't do this? Got it wrong. Okay. Times 2 times 1000. 25. Okay, so 0.024. Ijo, you got this correct?
Yeah.
Okay. Now, from mole per decimeter cube to gram per decimeter cube, from here to here, you multiply the molar mass. So you need to find the molar mass of HNO3. So what's the molar mass of HNO3? 78, right? 60 what? 63. Okay. So you multiply 63. So 1.512. Okay? You got it correct? Okay. All right, now we're going to do the next step from this, which is oxides. Please turn to this page, this one. This one. Okay. Ijo, can you find this paper? It's the one that is two pieces, but I want this one. Page 3 only. This one. Okay. Can you find it?
Wait.
Uh,
Yeah.
okay. Now, what are the oxides? Okay, what are the oxides? Do you remember? I hope you do. So they are metal oxides. Okay, metal oxides are basic. Non-metal oxides are acidic. Okay, can remember? Okay, metal oxides that are basic like copper oxide, magnesium oxide, these are basic. Okay. Non-metal oxides that are acidic are like sulfur dioxide, nitrogen dioxide, and so on. Okay. Now, the special category of amphoteric are only two, zinc oxide and aluminium oxide. What does amphoteric mean? Do you remember? Can react with acid and alkali, can react with both. Okay. So, basic oxide reacts with acid. Acidic oxide reacts with base. Amphoteric reacts with both. Okay, can. All right, and then finally, neutral oxides like water. Okay, carbon monoxide. These are neutral. Okay, let's do this together. Remember, what is the main cause of acid rain? Sulfur dioxide. Okay, which will give a solution with a pH 14. Which one is the alkaline? Same as just now the answer. Na2O. Because Na2O dissolves in water to form NaOH. Okay? Alright. Which is colored? Okay. Colored, I think I taught you this that day. Transition metal. Okay, so in all of this, there's only one transition metal. So the only one transition metal is this. Chromium. Okay. Finally, this one. Major impurity of iron ore. Iron ore means you dig in the soil, you get iron. Okay, the impurity is sand. Can you tell me which one is sand here? Yes. Silicon 4 oxide is sand. The one that is amphoteric, I literally just told you aluminium oxide. Okay? Alright, and neutral, can you tell me which one is neutral? Carbon monoxide. Okay? What is meant by amphoteric oxide? Can react with acid and alkali. Okay. Does not react with acid or alkali. Okay? Okay, this question is about making salts. This is the whole thing that I taught you last week. Can you remember? Yes. Okay. Please try and do question 3. Okay, please try and do question 3. Ijo, you okay? Can understand?
Yeah.
Okay, good. Okay, try and do question 3, ah. Okay, Ijo can, ah? So remember this one? Uh, put it as base, ah, not alkaline. Okay. Magnesium sulfate and lactose sulfate. Okay, you need to know this is soluble. This is insoluble, ah. The method to make soluble salt and the method to make insoluble salt is different. I taught you all last week, right? Okay. A student prepared magnesium sulfate crystals. Okay, he's trying to prepare magnesium sulfate crystals, starting from magnesium carbonate, and the student carried out the experiment. So you make sulfate, so you use sulfuric acid. Magnesium carbonate. Okay, the student added an excess of magnesium carbonate to a small volume of dilute sulfuric acid until no more acid will react. A no more magnesium carbonate react, that means it's excess. The student then filtered the mixture. So here will be your excess magnesium carbonate. And here is your filtrate. Your filtrate is magnesium sulfate now. All the acid has been neutralized. Heat up until it was saturated, cool until crystals form, and then dry. How the students, the solid magnesium carbonate no longer dissolves. Okay, the solid magnesium carbonate no longer dissolves. Name the residue. Residue means the excess. So the question says name, please write name. What is a saturated solution? Okay, here, right? Saturated solution, you cannot write what you feel. You have to write actual definition. Okay, so a definition for saturated solution is what? Saturated is very, very concentrated. Okay, meaning that you cannot add any more solids. Okay, you can add any more solids. Okay, so you can either say the maximum amount of solutes that can be dissolved at a certain temperature, or no more solutes can dissolve. Okay, so maximum amount of solids can be dissolved in the solution at that temperature. Why at that temperature? Because if you increase the temperature, solubility increases. Sorry, not solids, solutes. Okay? And if you want to be more accurate, you can put here mass. Okay, why must we say at this temperature? Okay, why must we say at that temperature? Because if, let's say, the temperature is 30 degrees Celsius, you add and add and add magnesium sulfate. This is the maximum. Okay, if you increase the temperature to 40 degrees Celsius, can it dissolve more? Yes. And if you decrease the temperature to 10 degrees Celsius, what will happen? It will not dissolve anymore. So the ones that you added in just now will start to form crystals. So that's your answer here. Explain why magnesium sulfate crystals form. Because when you cool it, the solubility decreases when temperature decreases. So when you cool it down, the solubility decreases, the crystals start to form. Can you understand? Okay. Do you do the calculation question already? Yeah. Ijo, do you do the calculation question? Yeah? Okay.
Yeah.
All right, good. Okay, let's see this. Calculate the number of moles of water. Okay. So the number of moles of water, first you calculate the mass is 2.52. So moles is mass over molar mass. Okay, did you get it? Yeah, so 0.15. The number of moles of anhydrous. So this one is hydrated, right? Okay, so anhydrous, you take 4.92 minus 2.52. So the mass would be, sorry, 2.4. Okay, and then the moles, you take 2.4 over 120. So you will get 0.02. Okay, ratio, you just take, divide the smallest number. 0.02 divide 0.02, you get 1. 0.14 divide 0.02, you get 7. So the formula is MgSO4 dot 7H2. Okay? What did you get? Okay. So this is hydrated, okay? This is hydrated. Can? All right. Okay, this question. This question is to make a insoluble salt. Insoluble salt, you take soluble plus soluble. Okay? The soluble plus soluble. So, for example, if you're making lead sulfate, your lead must be in an aqueous form, your sulfate must be in an aqueous form. Right? So, I already told you before, The easiest is nitrate and sodium because all nitrates are soluble, all sodiums are soluble. Okay? Always use nitrate. So if you want to do lead, then you do lead nitrate. If you want to do calcium, then you do calcium nitrate. Okay, and then sodium, because everything sodium is soluble. Sodium sulfate, sodium carbonate, sodium chloride, all soluble. Okay, so this will automatically go and find this to form lead sulfate. And the leftover is water. Sodium nitrate aqueous. Can? Okay, but what you must understand is when you do it, you have to pour it together, right? Remember not? I taught you this last week, right? Yeah, last week we did this already. Did we do the insoluble also? Oh, we didn't do insoluble. We only did soluble lah. Oh, I'm so sorry. I'm so sorry. I'm so sorry. My fault, my fault. Last week we only did titration and acid neutralization. I didn't teach you this yet. The insoluble one I didn't teach you yet. Okay, I'll teach you now, I'll teach you now. Oh, I'm so sorry. This part. This part I haven't taught you. Okay, this one to make insoluble salt. Ijo, you have your notes with you?
Yep.
Okay, this one is specifically to make insoluble salt. Okay, so to make insoluble salt, the method is called precipitation. So you take a soluble salt plus a soluble salt, it will automatically become insoluble and another soluble. So for example, and for insoluble salt, I want to make silver chloride. Okay, of course you need to memorize lah. Silver chloride is insoluble. So this is a solid. So what you do is you take a beaker full of silver nitrate because all nitrates are soluble. Okay, so soluble means what? Soluble means the ions are stuck together or freely moving in water. Which one?
Freely
Soluble
moving.
are freely moving. Soluble means the ions are freely moving. So the nitrate is freely moving in between the water. Okay, and then you mix it in a solution with, you can use sodium chloride because sodium chloride is aqueous and sodium chloride has chloride. Okay, this is what happens when they all mix together in one big swimming pool. Immediately, the silver will go and find the chloride. Immediately, the silver will go and find the chloride. Silver, chloride, they immediately will go and fight each other and they will stick together and they will form a solid. It's still silver and chloride ion, but because they stick together now, they are a solid. So a solid that suddenly forms, it's called a precipitate. Get it? So who is left over? Sodium nitrate lah. So in order to get this solid, all I need to do is filter. So now, the silver chloride is my residue or my filtrate now? Residue. So all I need to do is rinse with distilled water, dry between filter paper. Get it? Okay? So every time you want to make insoluble salt, it's always the same method. But you have to start with an aqueous solution. Okay? And what happens is the silver that is in the aqueous solution form and the chloride that is in the aqueous solution form will find each other and become silver chloride solid. Okay, can you write this down, please? Okay. Okay, okay. All right. Joe, you okay? Can go back to the question?
Okay.
Yeah. All right. So this case, okay, is exactly the same. Okay, it's exactly the same. It's precipitation reaction. But uh, look at something that I have to do before I start adding everything together. No, no, no. Look carefully. I cannot just mix together. What does it say in the question? It is made from crystals. No, this is solution. Sorry, sorry, sorry. Some questions, if they start with crystals, you cannot just mix together. Okay, in this question can, because they start with solution. Certain questions, they say you have solid, so you must make into water. Okay, so how do you explain? So in a figure, mix the lead to nitrate and sodium sulfate solutions and stir with a glass rod. Okay, okay. All right. Filter the mixture and then rinse the residue with distilled water and dry between filter paper. Okay. That's it for 4 marks. Okay. All right. These are ionic equations. So this is what I was talking about just now. Okay. Ionic equation between lead 2 nitrate and sodium sulfate include the state symbols. So lead sulfate become lead sulfate and this one is solid. Okay? Okay. Everyone understand? Can? Can I? Okay. Ijo, you okay? Can I go to the next paper?
All right.
All right, can I? Okay. Now, okay, we're going to do a similar question. Okay, we're going to do a similar question. I want you to turn to this one. Page 3 for your one, page 3. This document, okay? This document. All right. Barium carbonate is the insoluble solid. Okay, barium carbonate is an insoluble solid. When barium carbonate is heated strongly, it undergoes something called thermal decomposition. Okay, thermal decomposition is like this, where you just take a compound, you heat it up, it splits apart. Only one reactant. If it's only one reactant, it's a decomposition reaction. That means it breaks apart. Okay, write the chemical equation. So this one, you haven't learned yet. I'm teaching you now. So when you take carbonates and heat up, right, it will become oxide and it will release carbon dioxide gas. Okay. All right. Barium is in group what in the periodic table? Barium is in group 2. So it's a metal. When a metal dissolves in water, what does it form? Acid or alkali? Huh? Alkali, metal. Metal oxide is a base. Okay, so dissolve in water become alkali. So the pH is about 13, 12 to 13, 12 to 14. Okay, you can write 13 also, you can write 14 also. Okay, this equation, right, I'm going to teach you barium nitrate. Thermal decomposition means I heat up the salts. Barium nitrate, if you heat up, it becomes barium oxide, nitrogen dioxide, and oxygen. Okay, the question is asking the two gases products. So nitrogen dioxide and oxygen. So this one and this. Okay, can? Okay, this is literally what I just taught you. I literally just taught you this. Okay, so I want you to do this and this. Can? Got it? Got it? Yes, yes, yay! Show more enthusiasm. Yay. Okay, do it now, do it now. Okay, let's do this first. Chemical equation. Sodium carbonate, barium nitrate, barium carbonate, sodium nitrate. Correct? Okay. All right. Close enough. Yeah. Okay. How a pure sample of barium carbonate can be obtained from the resulting mixture? So filter the mixture, rinse residue with water, dry between filter paper. Ijo, are you back?
Yeah, yeah.
Okay, did you get this correct?
Uh, no.
No. Okay, okay. Okay, let me know when you finish copying, then I can go to the next question.
All right.
Okay? Alright. Barium carbonate reacts with dilute hydrochloric acid, 9.85 gram of barium carbonate. Okay, first we use how much barium carbonate was used? 9.85 over 197. So you get 0, 0.010 near. Okay. How many moles of carbon dioxide were made when all the barium carbonate reacted? Okay. So please take note, excess hydrochloric acid. So this hydrochloric acid is in excess, okay. So if this one is 0.05, this one is also 0.05. The ratio is 1 to 1. Okay. The volume of carbon dioxide, you multiply molar volume. How much you get? Okay. How many moles of hydrochloric acid was in excess? Okay, so first you calculate the amount of moles of hydrochloric acid. So M is 1, V is 250. So you get 0.25 mole, right? Okay, 0.25 mole is the acid that was used, that was provided, not used. Okay, this is the amount of moles of acid that is provided. Okay, how much hydrochloric acid was used? So if this one is 0.05, this one is 0.1 because it's double, right? Okay, so used is 0.1 mole. So excess is 0.25 minus 0.13. So you get 0. Got it? Okay. Ijo, you got it? Did you get it correct?
Yeah.
Okay, very good. Um, okay. So now, uh, this one, right? Okay, so we have two more. Wait, okay, this one and this one. Okay, So we still have these two. So this one discuss with you. Okay, so we have this paper, haven't done, and this paper haven't done. Okay, can? Do you think you guys can do it as homework? Huh? Yeah, this one and that one. These two. This one and this one. Electrolysis. There, this one lah. There, this one lah. Ah, do also lah. Can ah? Got time or not? Or you want to study for exam? Okay, okay. If you want to study for exam, then no need, no need. We'll discuss it next week. Okay, I know you all want to study for exam, then no need. Okay, we'll come back and do it. You just have to remember what we learned so far.